Hello and welcome to our lesson on multiplying polynomials. So in our last lesson, we looked at adding and subtracting polynomials, different vocabulary parts related to polynomials, terms, etc. And we also looked at the idea of combining like terms. So again, you'll want to make sure you have a good foundational understanding of those pieces before moving into today's lesson. So today's lesson is looking at different ways we multiply together polynomials. So the first method that we're looking at is known as the FOIL method. And we use the FOIL method when we are multiplying two binomials. So that means two terms in each. And this FOIL method works only when we're dealing with two binomials. Later in the examples, you'll see what happens when we're multiplying binomials and trinomials or larger polynomials. So to begin with, the FOIL method is an acronym that stands for first, outer, inner, last. And that acronym tells us the order that we need to multiply our terms. So what this means is we multiply the first terms, the outer terms, the inner terms, and then the last terms of each polynomial, or binomial in this case, before we do any of the simplifying or combining like terms. So let's take a look at our first example here, example 1a. We have x minus 5 multiplied by x plus 7. So we have two binomials. So following the FOIL method, I need to multiply the first terms. So that would be x to x. So I'm going to multiply x times x, which gives me x squared. Then I need to multiply the outer terms. 7 and x. So we're looking at our outer terms. 7 times x is a positive 7x. So right now we have x squared plus 7x. Then we move to the inner terms. We have a negative 5 because it's a minus 5 and an x. So our inner terms multiplied, negative 5 times x, gives us the minus 5x. And then our last terms, a negative 5 and a positive 7, gives us a minus 35. So once we use the FOIL method, first, outer, inner, last, we end up with our larger polynomial expression here. Then to get our final answer, we simplify and combine like terms. So our x squared has nothing to combine with, so that's just x squared. Positive 7x minus 5x gives us plus 2x, and then the minus 35 gets brought down. So our final answer would be x squared plus 2x minus 35. So again, looking at the FOIL method for b, we need to multiply our first terms, so x and 7x, which gives me 7x squared. Then our outer, x times 1, is just x. Our inner, negative 3 times 7x, is minus 21x. And then a negative 3 times 1 for our last is a negative 3. So we have 7x squared plus x minus 21x minus 3. Then we need to combine like terms. 7x squared is the same. Positive 1x and negative 21x gives us a negative 20x. And then bring down the minus 3. For c, our first terms, 9x and 4x, gives us 36x squared. Our outer terms, 9x and 3, gives us 27x. Our inner terms, 4x and positive 2, gives us plus 8x. And our last terms, positive 2 and positive 3, gives us a positive 6. So then, combine like terms, 36x squared has nothing to combine with. 27x plus 8x gives us 35x plus 6. So then 3 more examples to look at. So in D, just again following FOIL. I'm not going to worry about walking through step by step there. You can see it. Give that one a try. In E, we now have an x squared in a binomial. That changes nothing about the FOIL approach. We just now have to be careful to use that exponent of 2. So when we do E, we still use the FOIL. 13 times x is 13x. Outer, 13 times 2 is a positive 26. Inner, negative x squared times x. So again, we have to add the exponents. A 2 and a 1 gives us a 3, and it's a negative. So it's minus x to the third. And then a negative x squared plus or times a positive 2 gives us a minus 2x squared. Then I want to combine like terms if there are any and write this in standard form. So my largest exponent value has to come first for standard form. So the negative x to the third comes out front, minus the 2x squared, plus the 13x, plus 26. And same thing with f. Now we have 2 different x squareds in the binomials. We still can FOIL it. So multiply our first terms, giving us 2x to the fourth, 2x squared times x squared. Outer, 2x squared negative 6 gives us the negative 12x squared. Inner, negative 7 and x squared gives us minus 7x squared. And last, negative 6 and negative 7 gives us a positive 42. Combine like terms, 2x to the fourth minus 19x squared by combining these two, plus 42. So the FOIL method always works when we have 2 binomials. In example 2 here, now we're looking at what happens if we have binomials and trinomials or larger polynomials. So what we want to do for this one is we want to take each part of one of these. In this case, I break apart the trinomial and we multiply it by our binomial. So what you can do, and what I mean by that is, if we look at this first one of A, we have the binomial x minus 4, and then the trinomial x squared minus 11x plus 8. So what I did is I kept the x minus 4 together. So you'll see in each part of this, the x minus 4 is still together. I took each part of the trinomial, and we will be distributing that, meaning multiplying it by the distributive property to each part of the binomial. So what this problem can be broken down to is x squared times x minus 4 minus 11x, because it's a negative, times x minus 4 plus 8 times x minus 4. So then we're going to take each part on the outside and distribute it to each part of the inside. So x squared times x is x to the third. Negative 4 times x squared is minus 4x squared. Negative 11x times x negative 11x squared, negative 11x times negative 4, positive 44x. Then 8 times x, positive 8x, 8 times negative 4, negative 32. Then we want to combine like terms. So x to the third is on its own. Negative 4x squared minus 11x squared is a negative 15x squared. Positive 44x and positive 8x is a plus 52x. And then minus 32 at the end. So in B, we want to break apart the trinomial. So this can become 2x to the third times the binomial of 2 minus x squared, then minus 9x squared times the binomial of 2 minus x squared, and then minus 11x times the binomial of 2 minus x squared. Then we need to distribute for each part of this. So 2x to the third distributed gives us 4x to the third minus 2x to the fifth. The negative 9x squared distributed, negative 18x squared plus 18x to the fourth. And then the negative 11x distributed is a minus 22x plus 11x to the third. Then we want to write this in standard form and combine like terms. So the negative 2x to the fifth comes out in front. Our 18x to the fourth is next. Then a plus 15x to the third, which came from the positive 11x to the third and 4x to the third being combined. Minus 18x squared, which is on its own. And then minus the 22x. And in example C, it's another one that you can try here, but you can see, again, break apart the trinomial, multiply it by each part of the binomial, and then combine your like terms. Now, in addition to these examples, I will tell you that practice on this topic and this approach is pretty important. It's a brand new skill to you. So take your time, make sure you're using the FOIL method or distributive property where you need to, and I will include a few extra videos to use as resources where needed.